welcome you to our chemistry class today. In our discussion during this lesson, we shall be looking at the contact process, which is the large-scale manufacture of sulfuric acid the contact process. And why do we require this sulfuric acid in large scale? What is the importance of this compound in human life and also in industry? Some of the uses of sulfuric acid, one of them being the manufacture of fertilizers, the processing of metal ores, manufacture of detergents, manufacture of plastics, manufacture of dyes, and also paints. It's also used in lead acid accumulators. With all these uses, this is a clear indication that sulfuric acid is a major requirement in industry, and it has many uses as indicated by what we just mentioned as some of the uses. The raw materials for this contact process, one of them is sulfur 4 oxide, and the other one you also require air. There is also concentrated sulfuric acid, but because it's also produced in this process, we will just mention it as we are going to consider it in the flowchart. But these are the two main raw materials: sulfur 4 oxide and also air. However, to obtain sulfur 4 oxide, either sulfides, metal sulfides, or sulfur in itself is burnt in air, can be burnt in air to produce sulfur 4 oxide. So if sulfur is burnt in air, it combines with oxygen to produce sulfur 4 oxide. So that is one way of obtaining this sulfur 4 oxide. Let's look at the flow chart for the contact process. So sulfur on this end with air, introduced into the burner, where now you have the burning or the reaction between sulfur and air to produce. You have to look at here, it produces sulfur 4 oxide gas, and then it's also going to be unreacted air for that. Then the sulfur 4 oxide and air into the cleaners and dryers. Cleaners to clean and remove all impurities, dryers to remove any moisture or water vapor in this gas, because you know the impurities, dust particles and other form of impurities will actually poison the catalyst that we will also consider in our the process. So cleaners would remove the impurities, the dryers will remove the water vapor. So whatever mixture of gas exits this chamber here also will actually be free from dust particles and also free from moisture. Then this mixture will enter the heat exchanger, where you also have temperatures inside that heat exchanger being very high. We'll have temperatures being very high, and then you have high temperatures of about 450 degrees to 500 degrees Celsius. Then this mixture of air will actually enter the catalytic chamber, where you now have the catalyst, and there are two forms of catalysts in this catalytic chamber. We have the first type of catalyst that can be used is the vanadium 5 oxide, and the other one is platinum. However, vanadium 5 oxide is the one which is the most preferred in terms of the usage in the catalytic chamber, because vanadium 5 oxide is cheaper and it is also less poison. However, in this catalytic chamber, this is where you have the conversion of sulfur 4 oxide to sulfur 6 oxide. That's why you see the gas exiting on this other end is actually sulfur 6 oxide back into the heat exchanger. Then now, through the heat exchanger into the absorption tower, where you now have the concentrated sulfuric 6 acid combining with this sulfur 6 oxide to produce oleum. So oleum, the formula is H2S2O7. So the concentrated sulfuric 6 acid combines with sulfur 6 oxide in the absorption tower to produce oleum, and then oleum gets into the dilution chamber, combines with water to now form sulfuric 6 acid. That is briefly a summary of this, the flow diagram that shows the contact process, the industrial manufacture of sulfuric 6 acid. Now, let's just briefly look at what happens at each of the steps. At the burner, either sulfur or sulfides are burnt to produce sulfur 4 oxide, and this is the equation for that reaction at the burner, and that is why the gas exiting this burner is sulfur 4 oxide and also the unreacted air. At the cleaners or the dryers, the dust particles, the impurities are removed so that the catalyst is not poisoned. Dust particles can be removed by also electrostatic precipitation. At the heat exchanger, this is where the gaseous mixture are preheated to attain a suitable reaction temperature. And then at the catalytic chamber, you have either platinum or vanadium 5 oxide, but by way of mentioning, vanadium 5 oxide is the most preferred because of it being cheap and also less easily poisoned by these impurities and the dust particles. Then sulfur 4 oxide and oxygen react to produce sulfur 6 oxide. This is where we talked about the conversion of sulfur 4 to sulfur 6 through the oxidation and actually catalytic oxidation of that sulfur 4 oxide to sulfur 6 oxide. Now, sulfur 6 oxide is not dissolved directly in water. Ideally, you would have expected sulfur 6 oxide just combined with water and it gives you sulfuric 6 acid. That is not the case because the reaction between sulfur 6 oxide and water will result in a reaction which is very exothermic, which will lead to the boiling of the acid and then production of droplets of sulfuric 6 acid in the air. And this is not applicable. It is actually dangerous, and that process is not applied here. However, the gas is dissolved in concentrated sulfuric 6 acid to form oleum, and oleum is that oily liquid with the formula H2S2O7, and this is the equation for that reaction: sulfur 6 oxide with sulfuric 6 acid to produce oleum. Then this sulfuric 6 acid will actually be obtained by diluting the oleum with water, and that happens at the dilution chamber. Then you end up with your concentrated sulfuric 6 acid, and this is the equation: H2S2O7 with water to produce sulfuric 6 acid. That is a brief description of the contact process, and that brings us to the end of our discussion on the contact process.